we have a non-ideal inverting operational amplifier. And we're going to analyze it and then compare our analysis to that of an ideal inverting amplifier. That's coming up right now.
Hi, I'm Dr. Bob. There are no lectures here. I just solve problems, homework problems to help you understand how to do them. Electrical engineering, at your service.
I'm Dr. Bob, and today we're going to go over what is a non-ideal op-amp analysis. This is the case where we don't have an ideal op-amp. And in this problem, what we're looking at, this operational amplifier is non-ideal, has non-ideal properties, as do all real operational amplifiers. So in this case, we have an input resistance of 450 k ohms, an output resistance of 2.5 k ohms, with an open loop gain of 400,000. And in part one, there's three parts. Part A is calculate the voltage gain, that is V out over VG, where VG is the input voltage and V out is the output voltage. Part two is calculate Vn, that is, here's Vn, which is the input to the operational amplifier, when VG is equal to 60 millivolts. And then part three, calculate the resistance that's seen by VG. That is, what the resistance profile looks like when it's looking back this direction. What does VG see when that happens? I don't know why I'm using the mouse. I've got a pen right here. And in part two of this problem, we just repeat steps A, B, and C for this case if the op-amp is ideal, and compare the results from what we got. Okay, so let's begin. Whenever you have a non-ideal amplifier, in this case, we can model it best. As said before, we had an input resistance of 450 k ohm, and that's modeled here as 450 k ohms across the output or across the inputs. The 2.5 k ohms output resistance is basically represented here. Open loop gain of 400,000 is represented here, and what we put this is A equals to, basically it's going to be BP minus Vn multiplied by 400,000. Okay, so that's our open loop gain. And the next thing we're going to do is write some equations. Now, the first equation we're going to write is at this point at this node right here. And of course we're going to use KVL again, or KCL. Just look at the currents going away from this point. So our first equation is going to, we'll call it equation 1. It's going to look like this. It's going to be V sub n minus VG divided by that first input resistor, which is 15 k ohms, plus V sub n minus V out divided by the 300 k ohm resistor between them, plus Vn now minus Vp and divided by the 450 k ohm resistor between them. And all that adds up to 0. And then the next one I'm going to do is of course going to be at the V out node. Looking at the currents going away from V out, and that's going to be equation 2, which is going to be V out minus Vn divided by 300k plus V out minus, well, it's going to be A times, actually, yeah, A times VP minus VN. So, and that's going to be divided by our input resistance of 2,500 ohms, or 2.5K. And all that adds up to 0 as well. Okay, so here are two lead-in equations. We have these two equations, equations 1 and 2. And this first equation, we're going to take care of it by just multiply everything by 900K, and that's ohms. And the second one, we're going to clean that one up by multiplying everything by 300K ohms, and that's, of course, is ohms down there. And when we do that, equation 1 comes out looking like this. We get 60 times Vn minus Vg plus 3 times Vn minus Vout plus 2 times Vn minus, no, that's it, Vn. And of course, when we know that when we did this, Vp was ground, so that's equal to 0. So Vp drops out of this equation in two places. So let's get rid of these two guys right here. Yeah. All right. All right. Back to pencil. And all this equals 0. And then on the second equation, this comes out to Vout minus Vn plus, it's going to be a big number, 120 times Vout plus A times V sub n. Alright. And that equals 0 as well. Okay, dare I go further? Okay, so a little bit more playing with equation 1, and we're going to just add terms here. V sub n times 60 plus 3 plus 2 plus V sub g times minus 60 plus V out times minus 3 equal to 0. So what I've done is I've just added some terms up here. I've got a 60, 3 and a 2 scattered around, so collected terms. And in equation 2, we'll do a little bit of term collection also. V out times 121 plus V sub n times A minus 1. And that adds up to 0. Now A is equal to 400,000, so that minus 1 is probably not going to do a lot. So let's solve for Vn over here. In equation 2, we get a solution for V sub n is equal to minus 121 V out divided by 400K minus 1. And we're going to take this Vn from equation 2 and plug it back into this Vn over here. And this comes into equation 1 becomes 65 times minus 121 V out divided by 400,000 minus 1. That's plus Vg times minus 60 minus 3 V out. All that adds up to 0. Now, of course, if we'll play with that a little bit, and we'll get a ratio of VG or V out. So we just solve this equation for V out over VG, and I'll let you do the numbers. I get a minus 19.87, and that's our solution to part 1A.
Thanks for watching my program.
If you like my videos, be sure and subscribe to my YouTube channel. And for an organized listing of my YouTube videos, go to my website, www.wherearemyplacebos.com, and click on videos. Have a great day.